right, welcome everybody to Passive House Accelerator Construction Tech. And Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles, interviews, produce weekly virtual confabs like this one, and we work to elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, videos, and podcasts. And we're really happy that you're here. We are going to hear from Ian Robertson in a moment. Passive House Construction Tech Tuesdays is a production of Passive House Accelerator with our co-hosts, Sean St. Amour, Kevin Brennan, and Mark Willey. And we've launched this to share the technique, and the technology of passive house construction tech. So each week we welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. So we welcome folks from all corners of the construction and design world to join us each week, and we're very happy you're here. Thank you.
I'm going to jump on first here, Kevin and Mark, because I typically post rules for our events, behave, mine, taking over the speaker session and be safe. But this is a different day. Today, because Ian's going to go really fast, it's all about enjoying today's passive house construction tech, where you need to be aware that it's going to last 15 minutes. So sit down, hold your armrest, get comfortable, keep your hands in at all times. This is going to be fast with a PH. It's going to be furious with a PH. And I will assist you at the end of the ride with the question period. So strap yourselves in, everyone. It's going to be fun.
My name is Ian, and this is the 6 flavors of mass timber. And slides are not dancing. Okay, so yeah, 134 slides ahead. That'll be going a little fast. And we'll do the Canadian version of it today. So about me, I've been in Vancouver since 2011. It's my first passive house, also first mass timber project. Had a good team along with it. So Mizzou Passive House with Pierre-Andre Santin. So he was a passive house consultant. Olofsson Construction and Volta have done passive house before. And then Aspect Structural Engineers, they're the mass timber gurus in Vancouver. And so having them around was really good. I'd used them, worked on them with them before on a project. So I knew that they were good, but they always say, don't be the only first timer on a project. And so I wanted to make sure that I was the only one who didn't have experience with one or the other things. Okay, so why mass timber? I like big windows, and you'll see why this matters in a bit. And what does big glass have to do with it? Well, we'll get to that. So what is mass timber exactly? And it's odd that it's actually in code-wise tricky, because mass timber until the recent code, at least in Canada, didn't actually exist. You had heavy timber, and you had weird things that you had to do with specific nailing patterns on specific thicknesses of 2x4s. When you nail them together, you get a fire rating out of it. Doesn't actually have any structural values with it or anything. It's just this prescriptive thicknesses. And then you got some weird thicknesses. What exactly, where does one get a 2x5 or a 2x7? So yeah, I'm foreshadowing to later. The other option is timing grooved. So you've seen these on cabins quite often. Again, different thicknesses equal different fire ratings, and you get to add a little bit more fire rating with some gypsum. And yeah, cabins are made out of this, but oddly, no one really uses it for mass timber type buildings, so even though it could be useful. And then you've got big, huge beams, and recently glulam beams are also in there, but that's basically been it. So the way that you use these things is you get an engineer to do an equivalency, and they do their calculation magic, and then you can use some of them. But still, it's different than having it baked into the code itself. So then the mass timber that we use 6 different flavors of it. So we use NLT, which is one of the existing ones. We used LVL, which is basically thick plywood. We use DLT, which is if you take NLT, but you put it together with wood instead of nails. LSL basically looks like OSB. but thicker. GLT is everyone's seen glulam beams. You can make panels out of it as well. And then PSLs, again, you see them as beams quite often, but that's about it. There's a bunch of others that we didn't use. Cross-laminated timber. There's a weird one that's available in BC that I would kind of like to see more of, but I have otherwise no idea. And then I think if you take those tongue and groove panels and put them together, you could make a panelized version of it as well. With NLT, you can do any wood species, stiffness changes with the different species. You can either stagger joints within a panel or do continuous, stiffer if you do continuous. LVL is the thick plywood, or you can flip it on end, so all you're seeing is the end grain. DLT, it's only one supplier in North America so far, but it's available in Europe more. We used a thinner panel with it, which is about 2 feet wide, but you can get big panels as well. LSL is what Simpson strong walls are made out of. So this is what you use to make a nice wood moment frame without having to blow your brains out on fancy engineering. Glue laminated beams. You can get huge things. We didn't need them all that big. And then PSLs, we use them for some headers. So each of these types of mass timbers has something that they're really good at and something that they're less good at. So if you're going to use a bunch of them, you have to know why. And in the case of our project, each one was chosen for a specific intrinsic property that none of the other ones really had. But you kind of have to be careful on a project because you don't really want to have to supply only one beam or one of something. You know, it's shipping's involved and everything like that. So it only makes sense if you're doing enough to make a truck work. So some background on the project. Vancouver is cool temperate. It's a green climate. We have a slightly wider than normal lot, limited views, nice front yard. So we wanted to have big windows near grade and smaller windows above. I didn't necessarily want a passive house, but they wanted something that was more energy efficient, semi-autonomous potential, really, really quiet, always comfortable. And there's a really, really long wait time if you did a regular permit and a much shorter wait time for a passive house. So if this were math, you tended towards passive house. You know, there's a lot of things that added up to it. Recently, they've actually changed the rules further. So whereas we could, after a lot of complicated math, exclude 15% of the overall area from gross to net, now you can just do a lot simpler calculations and exclude 16%. So it wouldn't have improved our situation all that much, but it would have meant that I didn't have to calculate it 20 times plus. So there's an interesting incentive here now, though. It's actually to make walls even more efficient, because if you could actually code minimum wall, in theory, that 16% bonus area would just be entirely that, a bonus. So it completely shifts what the incentives are. So not only do you have to care what the building's made out of, you have to start caring about how efficient your wall assembly is. Yeah, it's a new challenge, and there's always new challenges. The zone that it's in, you can do a peaky roof or a flat roof. You get a little bit more height if it's peaky, but most peaky roofs, you have head height issues at the edges. Not if you do a butterfly roof. So that's what we did. Most houses in Vancouver seem to be doing this now. You have about half of the facade is glass, half of it is solid. But you know, what if you want to make it wider? What else do you do? So if you want to do that, well, first we tweak the roof a little bit to make it more interesting, conform to the program, cut in the middle, lift it on blocks, and then add a bunch of glass in the middle. Punch windows according to the program. And honestly, if my design process was a meme, yeah, this would have been it. So the next one was rotated the roof about 30 degrees, and that just made the facade a little bit more interesting. Combining porch and light well together allowed it to be a much wider front facade than we would otherwise be able to do at grade. And then what that got us was, on our 40-foot wide lot, a slightly inconveniently long span for using normal materials with. TGIs, you can do low 20s fairly easily, but to do a 26-foot span, I think you need a 16-inch deep TGI, and even then, it's still going to be a little bit bouncy. So what that meant was we were in different territories. So either we would have to use steel or something like that, or we could use mass timber. And that's when the path on this house became a mass timber one, especially. So the house had split between a basement suite and the upper house. You actually enter into the basement technically, and the floor has, as long as the floor is maximum 6 feet above grade, anything below it counts as basement. So that was the one limitation. That meant that this floor had to be as thin as possible, otherwise we had to drop down too far. So you drop down a couple steps into the basement, which is the entry. The suite can only be 6 feet below grade. You had to have 1 hour rating between the suite and the living area. You can only do 12-foot high ceiling for the living space. And it's so once you add all these things together, there are certain materials that were better or worse for each different instance. So the first one we're going to look at is NLT. The living room floor had to be NLT. It started out as 2x4, but when we switched over to having a real actual basement suite as opposed to just a bigger house, we needed suddenly a 1 hour fire rating and a sound rating, which meant that the 2x4s had to get thicker. We had to use the 114 millimeter or 165 millimeter rules for that one. We also needed STC rating, so this was 4 inches of concrete. Now you could do a bunch of different assemblies with it. It was limited at the time that we could only use 4 inches of concrete, and that was it. But where do you find 114 millimeter, which is 2x5 timber? So on this side, it didn't really matter as we were framing the floor over. This side, we could just use 2x8s. But on the other side, we actually had to cut them down and make them 2x7s. So we cut these out of the 2x8s 1 inch out, because otherwise we lost 1 inch of head height in the basement. Stephen hopefully is on speaking terms with me still, because they had to rip down, about 100 of these things. We did use them, put them to good use though, because we used them as cladding the bathroom later. So 114 millimeters is 2x5. That's what we had to rip down to make it. The we ended up getting an air cavity underneath it a little bit, because the 2x6s and the 2x5 plus drywall ended up being the same thickness. So where do you put pipes and everything else? Well, so the house starts out like anything else, with a big pit of gravel. So this is using a raft slab, a bunch of foam on top of it. And then it starts to get weird, because this is where we put all the HRV pipes also. And we did that because, of course, we didn't have any ceilings to run anything in. And this holds true for the rest of the project too. One challenge in mass timber is, where do you put your sort of really banal surfaces? So measure many, many times before you pour some concrete in there. And then above the concrete, we've got our basement sit panels. So those arrived really quickly. We're not really talking about those today. So the thing I'm interested in is the thing in the corner there, although they are interesting. And you should watch the BS and Beer show that they talked about permanent wood foundations. If you want to eliminate a bunch of concrete from a project, it's a really cool way of doing it. And for some reason, everyone forgot that it existed, even though it's in code in both Canada and the United States. So these are the base plates for these Simpson strong walls. And so you can either use the one that they give you, or if you lose that one, you can make your own. Doesn't really matter. And so these are the second mass timber type, which is LSL. Interestingly, since mass timber isn't completely part of the code yet, if you're going to use it for its shear values, you either need to test it, which was what you can do with the Simpson panels, or you have to have a big reduction in what the capability is. So it ends up actually in some ways being less efficient structurally than a 2x4 wall, even though it's actually much, much stronger. So it's this weird superposition right now of both better and worse. So until they update the code, this will be the case. So the Simpson panels are essentially the entire lateral value of the house, although there's a core as well. They're doubled up on the south part of the house to increase the values. You can stack them 2 at a time on top of each other. You can't go 3 stories with them, you can only go 2. So then, because they're below grade, we added some waterproofing to them just to make sure that there was any moisture whatsoever, it wouldn't affect it. But inside we did put a primer on top of it just to seal it in, because the waterproofing stuff doesn't smell the best. So they're stacked on top of each other. And then spanning between that are the big glulam beams that are the main horizontal members, as well as the DLT panels. So the big glulam beams, they span anywhere between 24 and 27 feet. So not really all that far compared to what they can do. There's also a bit of a spectrum shear wall core in the middle. So the glulams are on the corners of each level, and then also at the roof peaks. And everyone knows what glulams are, so I won't go into it too much. You can get them really big. You can use them as panels as well. So instead of the DLT, we could have used them a GLT panel. Marcel used them on a house that he did because the other ones weren't as readily available at the time. Now at least there's some more panels available, and I understand you can actually get CLT for a small project. For a little while there, you couldn't. So the glulams, they were cut to accept the different beams and LT panels. And then spanning floor to sidewall, which meant that for the upper floor, we could actually reconfigure this whole thing later because none of the interior walls are structural. So in terms of leaving flexibility later, there's plenty of it. Meant for an interesting kind of cathedral looking space as well, because until before the walls were in there, it was a really cool space. And anyone who was at the social that was there back when we could still do socials got to see this thing in its glory. And at some point I want to do it again, just leave it in that state and not put any walls inside of it because it was pretty cool. So the glulam span across, and then the other material that we've got in this photo is the LVL. And you notice it's not actually connected because the two are completely independent systems in the house. So the LVL was the thinnest possible two-way span that we could do. And there's two different types of LVL that you can get. You can either get the one that looks like plywood or the one that is on its edge, which looks like just edge grain, and that's it. So the one that's edge grain was the one that was available for quite a long time. That's done by Briscoe. And I'm only talking about like big members here because you've been able to get smaller members that are like beam size for quite a long time. Recently though, Freres in Oregon have started making these big panels up to 12 feet by 48 feet. I think they're actually even putting a bit bigger press together as well. We were literally the first project that was able to use them because for an American project, they didn't have the certifications at the time. Whereas in Canada, it just needs a structural engineer to sign off on these things. So there's one important difference in codes in how the code treats mass timber in the two different countries. There is a similar project in Europe from Metza, and there's a few others as well, but at least in North America, there's currently only one. So we used it for the thin profile on the floor, but then we also used other elements of it for the walls, because we ended up having extra bits of it left over, essentially, because the way that we had to orient the panels. Let's see, here we go. I actually did the shop drawings on this. I wouldn't recommend anyone do this in the future because it's a level of liability and everything else I don't think architects really should probably be taking on. But since we were the first project from them, I did so anyway. And then the spaces in between the panel are actually taking into account the size of the saws and everything like that. So you actually have to, people who specialize in this stuff know this stuff intrinsically. This was all new to me, so it was interesting. So this was making maximum use of two 12 by 32 foot panels, and then taking all the extra little pieces of it that we could and using them for stair treads and other things. This is just a photo that I like, so I've included it. Nice, pretty photo of the underside of the LVL. And then we actually installed a lot of it after the entire envelope was up, which meant that it could be done on the dry. As you can see, there were a little bit of darkening from it getting a bit moist. And this is the big thing with mass timber. You have to keep it dry. And there are now products that you can do that with. At the time, there were fewer of them. This is the detail where the LVL hits the glulam right at the front facade. So we've got a window, a big window on top and below. And we're using these big fiberglass angles to hold them. The upper one's being held in bearing, the bottom one's just being held side to side. And then we've insulated it on the outside of that with a tricoya panel, which is basically like a waterproof MDF. It's pretty cool, although it's no longer available in North America because it's too popular, and it's staying in Europe. And then we did have to add a little bit of heating as well on this floor, just to make sure that our comfort criteria wasn't broken. So we've got about 10 watts per foot worth of heating, and the heating element is just this bar along here. So it's meant more for roof heat tracing, but you can totally use it inside as well. So then I really like the look of this LVL, so kind of wanted to feature it as many places as possible. So it cleans up pretty well. And then it was a lot of fun seeing all these big chunks of it lying around. And you can also see actually the space between the DLT and the LVL here. And it's only 2 screws that actually hold it laterally. And that's it. So then the interface between the DLT and the LVL here. So then what is DLT? So DLT is sort of like NLT, but they use big long hardwood dowels that are installed when it was really, really dry. And then when those acclimatize to the rest of the panel, they lock it all together. You can get either really big panels with it, and then you have to pay more to get them all the shop drawings and everything like that, or they're a lot cheaper if you get them in the narrow billet type, because they can just sort of crank those out more in an industrial process. So the bill of sale that I basically gave them was just a shopping list. Give me, 14 billets that were this many wide by this length by, that was kind of it. So it was a lot simpler version of a shop drawing than you would have for most types of mass timber. And then these were adjusted on site as they needed. So these clear span side to side. And this floor could have been either NLT or GLT as well. However, if it was going to be NLT, we actually had to have continuous members side to side. And finding 26-foot long 2x8s is a real challenge. Like, you can buy them from Alabama, I found out, and you had to buy an entire train car full of them if you want to do so. Unfortunately, we only needed a half train car, so that didn't really make sense. So this is when DLT entered the picture. Using the narrower billets kept the costs in check a little bit. So it would have been, the cheapest option would have been site building with NLT. Using the DLT like we did wasn't actually that much more costly once you figured out labor as well. And then 2x8s spanning this distance still aren't quite stiff enough. So if you add a layer of concrete and then lock them together with some steel, then you actually make a hybrid assembly, it's called. And this ends up 3 inches of concrete does a massive amount of work here. And then there's the 4-inch of concrete topping on the floor below. That one is actually doing no structural value whatsoever. It's only for soundproofing. So when we installed it with the wrapping on, because thinking that was going to protect it nicely. Then later we added some more waterproofing on top of that. The thing though was that moisture got trapped in on the top side of the DLT panels. And the humidity level increased a lot because there wasn't any drying potential. What that meant was these ate up all of the gaps that they were supposed to be installed, but they're supposed to be installed with a 5mm gap between each panel. We ate that up and then more when these things expanded sideways. So they actually were popping some screws. So you're going to see the missing screw head here and here. This is the lateral force of these things, basically shearing them off. So we then added it, after that was figured out what it was, the wood was allowed to dry later, so it could be pushed back in place. So that wasn't really that much of an issue. And then a big new steel angle was installed right at the corner here to recatch them and allow them to be secured again. And then, so this is how the steel and the concrete, the wood and the concrete were bound together. So steel plates were cut into the wood, angled slightly to the center line of the floor with a big dado blade. And then there was a bit of acoustic layer in between where the concrete would be. So this is like a crumb rubber with a waterproof membrane on the other side of it. So when it goes down, it looks a lot like nori. So this goes in between the different steel members. And it's held back a little bit from them so that the concrete and the wood can go as close together as possible. And then the space in between we could also use for some conduits. So this again is, where do you hide stuff? So this is where we put the wiring for the lighting in the living room was run through these conduits, which are running nominally perpendicular to the span, nominally parallel to the span direction. When the concrete was cast, we actually put some shoring underneath it and cranked up the floor very slightly so that when, with some camber, so that when the concrete was set, it would relax down flat. And actually ended up working pretty well. It was 3/4 of an inch, and I think we probably could have dealt with another quarter or so, but it ended up being pretty good. The other thing when you're using mass timber, where do you put banal things like toilet pipes? So this is a surprisingly challenging thing because everything's got to go sideways until you can hit a sidewall, because you don't have any drops, you don't have any place to hide underneath. So you either have to use wall-mounted toilets, for instance, or you have to use a floor-sitting, wall-exiting type toilet, and that's what we did. We used a bit of both. As a side note, the Philippe Stark ones from Duravit are really pretty, and they will do this. There's not a whole lot of other pretty ones that will, so it's something else to coordinate. And you can see the low voltage wires sticking down from the ceiling there. Low voltage, so we didn't have to have boxes. The HRV pipes were put into a small drop near the south window. The sprinkler pipes were mostly sidewall mounted, but were also by the window. They were using that same drop space. And then we ended up, originally we weren't intending to fur the underside of the LVL, but we ended up doing so because we had plenty of height, as it turned out. And it didn't matter losing, 1.5 inches or so. So that was just 2x4s on their side to create a thin furring layer for the sprinkler pipes on the north side of the house. So that's 5 different flavors. What about the 6th? Well, the 6th one is the one we didn't use very much. It was some PSLs, and we just used them for some headers. They count as mass timber and all. The interesting thing though is in this photo, the part that we had is a knockout panel, because it was designed with a basement suite, and so this was completely fire separated between the two. But we wanted to include future-proofness. So where it's highlighted here, that can actually be taken away. And with a couple stairs down on the room behind, underneath this staircase, we can connect the 2 units together so that the whole house then could be healed back to become 1 unit. Space underneath the floor in the front, because the upper basement and the lower basement are about 3 feet different in height. We used floor storage. So this is the hatches are made the same module as the carpet tile, so that the 2 are perfectly matching. You can lift one without even noticing it's there. And then where the knockout panel is in the middle, you would just have 4 steps down into the basement, and then the 2 sides will be put together. And the client ended up really liking the look of mass timber, so we just did some things like things that would have been covered. I would have thought that they would have been covered. We just left them open. So the edge of the MLT there was one of those instances. So this is the basement suite. You can see the NLT ceiling. So this is the 165 millimeter that we cut down to make it that dimension. The future pass-through would be following that arrow through that 1 bedroom. And then the essentially final living room with the DLT ceiling. The lights ended up being a little heavier than I would have liked, but such that happens. Offices have the same ceiling all the way through. There's a little bit of a kerf on each of the DLT, the lamellas, and that tends to help hide the gap between each panel. You can see it in this image a little bit. There's some gaps that look a little bit wider, but because there's a gap so often, you don't really read it very much. And then on the outside, not a mass timber, but it's a fun timber anyway, it's sequoia, and this is what we use to create the porch. The tricoya was used on the horizontal extensions. So this is the material that, like I said, it's just waterproof OSB. No longer available in North America because it's too popular in Europe. They're not going to send it here for a while. So we've had to search around. Basically, the only supply left in the United States is what we were able to get. So it's cool, but for at least 1.5 years, you won't be able to get it. So sorry, we use the rest. And here's the final building. So it went from this to this. And then recently, we got our plaque. And introducing the Stephen, which is also now a SI unit of measurement. for the windows. And that's all. So special thanks to, Pierre-Andre, so Passive House consultant, builder, Eric and Stephen, engineers, Bernard and Merdad from Aspect. And then, although I don't actually work at Abarc anymore, they took on a fun project that let me have a lot of playtime. So that was pretty cool. And then the Cunningham family, of course, who is the client for this.
Wonderful, Ian.
That's me.
Fantastic for all those. You can now exit your seats. If you need the garbage bins, they are located somewhere in your office. And thank you for joining us for this lovely ride of 6 flavors of timber. I will now take questions. But Mark, do you have any comments before Kevin jumps on?
I would say if everyone could take themselves off of mute and give a big applause to Ian, I think it's well deserved.
Bravo!
Yay!
Woo!
And Ian, you also get the second time award for most slides in a presentation. I think we again, the question is not completely full. I'm sure the questions are going to start flooding in, but that was pretty.
I would say it's the Arsenio Hall. Woo, 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 woo. Bring it back to the early 90s. Amazing project, looks great. The innovation, the technique, the technology, and the technicians that was the cleanest job site photos I've ever seen. And you can tell the craftsmanship was there. So very nice.
That is the benefit of it, like a lot of the mass timber, because it comes just pre-done. You've got a lot less cutting and stuff like that. So there's some benefits of that, certainly.
All right, well, let's dive into the questions. Hans, you got a couple? You get to start, get to kick things off. Or did Hans run off to get his Christmas sweater? Hans, you still there with us? The first one was, do they expedite PH permit applications in Vancouver? And then you also had
The DLT, whether or not that's site built.
Yeah, go ahead.
Well, at the time they were it was a different stream. So like, I mean, we all know that a permit doesn't take that long to do. So they basically just had some of the planners were just doing passive house stuff for a little while. So they were able to crank them out, as opposed to the regular process where you were just in a pile of paper for 12 months before you got looked at. And that's essentially what the difference was, that you're just in a lot smaller stack of paper. It was essentially the difference. Now they're not really making that same distinction anymore. The regular permits have gotten faster. The passive house ones haven't really gotten any faster, so they've stayed about the same. So it's not as much of a big thing anymore. But no, yeah, the DLT was not site built, but that was all structure craft. So they're just in Abbotsford, and I think they're doing a new big factory down in the States as well.
But I think with that, Ian, you said that the NLT was site built and that you saved 11 months on the permit because of the carbon sequestering.
11 months on the permit for it being passive house. Yes.
Oh,
yeah. So yeah, but Vancouver is also putting in that you actually have to prove now that you're doing passive house. Like even at the very, very beginning stages, you have to provide them all sorts of all the PHP and PHPP and everything else. So they keep upping the bar, because I think they had a couple projects fail. And so they want to make sure that isn't. So you end up eating some of that time that you would have maybe gotten as a bonus, because you have more front-loaded time that you have to make, for your consultant to do more math. And maybe even for your certifier, do some math, which was at this point, that didn't need to be done as much when we did this one.
All right. Yes, Peter, that was your question. He just sent me a private message to be like, what was my question? I'm like, you got it. Peter, fire away. Thanks, Hans.
Hello, and thank you, Ian. Yeah, the question is, with the butterfly roofs, does it create any difficulty with the pig troughs between the peaks, or like even for snow load or rain? Yeah, how do you lead the rain away?
The peaks aren't parallel is basically the gist of that. So because the two peaks aren't parallel, the valley actually has a slope to it. And so it's got an intrinsic 2% slope down the valley, taking it to the side. Good. And then I showed last time I presented this thing. So I'm actually using the EFIS layer for drainage. So all the pipes run down through the 4 inches of the EFIS layer. So they're exterior to the WRB, good, inferior to the cladding layer. So yeah, if there was an issue, it would be fairly easy to deal with later. And the pink stuff in this photo here is the WRB. That was actually pre-applied one layer in the factory so that they came to site with a bit of an umbrella. So I didn't have to worry about OSB getting wet.
Good.
And that's also Stephen on the roof with me, by the way.
So you have a great large scupper at the end of that to catch it all?
Yeah, well, I calculated based on Vancouver rain flows and stuff. So, I mean, Vancouver doesn't get the torrents. So it didn't need to be crazy big, but it would have had to be a lot bigger if we were other places.
Well done. Good.
All right, Harvey, you've got 3 questions. Mr. Pierre Andre answered 1. Pierre, don't go anywhere. I would love to get your input on this project as well, because you provided some great insight with the technology by looking at the PHP model. So you don't go anywhere. And yes, 0.15 was the air tightness of the walls, but 0.37 overall, because those windows measured in Stevens are a little bit leaky, but still very much passive house. Harvey, go ahead with the rest of your questions.
First of all, Ian, great presentation. Stephen, great job on building this project out. It must have been really a lot of fun and a little bit difficult at the same time with that challenge. So the first question was timing-wise, because it almost gives it a sense of it being all panel and pre-built. So from, let's say, by the time you did your raft slab, what was the time frame until you were enclosed?
I don't actually remember until the envelope was sort of sealed in. It wasn't.
Well, how long was the build out, Ian?
The full build was about 1.5 years.
Oh, okay.
Yeah.
Pretty long.
Yeah. So.
And then since Pierre answered my blower door question, thank you for that, Pierre. For Stephen, where did you mount the plaque?
It's mounted at the front entry as you walk down the stairs into the front door on the concrete wall.
Great. That's great. No picture of that, Ian?
Sure. I didn't realize
it's coming.
I didn't realize it had stopped sharing actually.
Stephen can probably answer your question about
that's where the
build time.
Well, go ahead. Yeah, I'd love to know about the build time.
I think from slab till roof membrane was, if my memory serves me right, probably about 7 months.
Well, that's pretty
we had
fast.
we had some portions of the project went really quickly. Other portions we had various fitment and installment problems that we had to kind of come up with solutions for. But in general, the shell was up with a reasonable timeline, and some portions of it went very easily. Like the roof panels themselves went on quite quickly. The foundation itself went up quite quickly, but some portions in between with, like Ian had showed, some expansion of the DLT floor system, things like that caused us some some grief in the middle, where we had to come up with solutions for that with the engineers.
And the Stevens window also wasn't a fast thing either. A big slider.
Just as a supplemental, what are the lessons learned here? If you had to go and do this again and replicate it, Stephen and Eric as well, what would you say would make it quicker? What would you change of this project? I mean, it's a beautiful looking project that's well thought out. Just curious, if you had to do it again, what would be the big changes?
For me, the low hanging fruit would be considering doing the NLT portion, like prefabbing it, maybe on site somewhere. It doesn't have to be built off site, but not nailing them in one at a time in place. And Stephen can comment on that. And the second one is the SIPS package. It came without any structure in it. So if I remember right, it took 12 weeks to install all the above grade SIPs. And that was, partly because the SIPs weren't uniform. They didn't come properly dimensioned, like they were long by 1 inch or short by a certain amount. So we had to mess around with that. But I would, next time I'd order it with the structure inside them, because we were cutting these panels open, putting in beams, bringing back up. It was a really frustrating experience.
Yeah.
So to add to Eric's comment about the SIP tolerances, it's possible that a typical construction may lend itself to just, using a crane or a high-ab and standing the things up. But in this circumstance, on a Vancouver-sized lot with these massively thick SIP panels, most of them are 12 inches thick, and they didn't come with lumber in them. So now with some of those, if you remember the roof line with the, it's got compound angles or doubled angles. So you're ripping 14-inch wide top plates with bevels on either side and setting them into sloped panels. So as you're installing them, on top of that, we were stringing corner to corner on these oblique planes to try to make sure that when you actually sat the beams and the roof panels on top, that they would sit flat without any air gaps. And as the panels came, if you didn't make any adjustments, it wouldn't have fit to an ideal tolerance. You would have had undesirable gappage. But it took a bit of messing around to tweak these things for sure.
Would you guys have done site built instead, maybe the next project or so? Because it'd be great to see cellulose in those walls. You know what I'm saying?
The SIPs are great. Like they have some advantage. The best thing would be like this one works pretty well for space, like for having a crane accessible, but being able to store and move the panels would have accelerated that. But yeah, site built. I mean, we've done the site built Larson truss system in the past. And it's a great system as well. But yeah, I don't know. Site building SIPs or with blown in might be. Yeah, I don't know how we would arrange that one, but it would be pretty neat.
Insulation wise, we since we had a lot of glass, we had to overshoot compared to what the insulation value would normally otherwise. We would have ended up losing a good bit of floor space had we done cellulose at least for the walls, because we were basically relying on an entire 12 inches worth of neopore plus the 4-inch ethos on the outside, and we were needing all of that insulation basically. If we had filled the furring cavity with insulation, we would still have needed probably another 6 inches worth of width had we gone a different cellulose assembly. The roof could have been done with it, and the roof could have gotten thicker. We were basically maxing out the envelope, and also we couldn't have gone too much lower on the lowest point here, so it would have juggled the roof line a little bit. It might have been able to be accommodated, but it also would have been pretty tight. So Vancouver gives an extra meter worth of height on a roof for a passive house, and it's kind of there for a reason, because you do end up having quite a lot deeper assembly, unless you're doing funky things where, I mean, we use the vacuum insulation for the roof deck, but using that on an angled roof would be trickier. Flat roofs are easy for that kind of thing too.
Just a quick observation and analysis of like the team that you put together. I think I was at summer camp one year, and Joe Lestiebrick was saying that innovation and excellence happen at the leading edge of TIPA. And it seems like you put together a team of, an innovative general contractor, craftsmen who were willing to learn things, an engineer who's being an early adopter of mass timber, yourself trying out passive house, Pierre as the passive house consultant. So you have like this, almost like Voltron team of like people that are willing to go out and try things and be excellent. And anyone out there that is like thinking about doing passive house, it's assembling those team members of people who really care and that are willing to stop, hit the pause button and learn. And the project shows for it. I mean, 0.15 is an incredible air tightness number. Like that's like, that would get my golden blow a door number twice on Tuesday for the city of New York. Like that's unheard of, the level of air tightness that it could be. I don't think the spaceship is possibly 0.15, and my one question is the windows and the sliding windows, they were locally made or supplied passive house windows, right? Who made it? Fenster?
They're Fenster, yeah. So I mean, they're good, but it's a big, huge slider, and it's hard for anybody to make one that's big and huge like that. I would have to flip back 100 slides to go back to the photo of it. But yeah, I mean, they by and large they perform really well. So
on my project, I always as the air tightness guy and the air tightness guy on site, the lift and slide doors are the bane of my existence. We can do an immense job. Lift and slide doors go in, and then boom, our blower door number's been blown up. So like just the fact that you guys tested without it and you know what that is great. But from my projects and a learning experience is that there are different levels of gaskets and hardware from Europe that you can get. And they, the European lift and slide doors come in level 1, 2, or 3. And that's their levels of air tightness that they've been tested to, because a lot of the larger lift and slide doors, that system is so big that it hasn't been tested. So they have to use the lessons learned from other projects. One of the benefits of Passive House is that every project is a test project, and we give feedback very, very quickly to these manufacturers of, your lift and slide door cost me almost doubled my air leakage number. So that's a good feedback point.
Yeah, this was literally the biggest piece of glass that you can get in North America, basically, is what we used for these. The frames actually had to have an extra centimeter of wood on all sides to accommodate the largest pane of glass that we could get. So it was right at the edge, and they had to be upsized to doing 888 millimeter glass, as opposed to 866, which is the way that they were originally spec'd. And the glass manufacturer did said, we will only make this if it's the thicker one, because it was right at it, and also using thicker spacer bars too. So the whole thing ended up growing a lot thicker. It grew the best part of an inch for that IGU just from that. The two things added together, it's pretty crazy.
That's awesome.
I want to echo.
You have a point, right? Good.
I want to echo what you said, Kevin. The design, the engineering, the pulling together of these materials, and then the installation, the craftsmanship. This is a team of ninjas, right? So the technical, the technique, and the technology is pronounced on this. And what you guys did with the SIPs to create this incredible roof, it speaks volumes. And it speaks volumes with a narrow wall assembly.
Oh, wow.
And so I just think that's brilliant. And I'm still spinning. Much respect.
Yeah, so those are the shop drawings also. So this is both my 3D model, and this is what I actually issued to the different SIP people. And because I didn't want to even consider trying to document these things in 2D and telling them this panel, this angle, and everything like that, it would have been a nightmare. So basically I just gave them the 3D model and they could figure it out. And by and large, they did. Yeah, pretty close, but definitely get the wood from the SIP manufacturer, because a 2x8 isn't necessarily a 2x8 everywhere. Like there's nominal tolerance, and if they make theirs, if their 2x8s are slightly narrow and you get ones that are slightly wide, that could easily also be why the challenge of installing ours. They're both within spec, just on different ends of the spec. And it can hit you in the face a little bit if you're not careful.
All right, cool guys. So we're at the point of the show where we ask the lead person on the presenter to talk about who their mentor is and who they have to thank, and who got them to where they are at this time in their life. So if we can hold off the questions, we'll hit everything up in the next section. And Ian, who is this?
So I'm being savvy. This is actually my dad. So he's a physicist and also a material scientist, which might come through a little bit in my stuff. So like books that he brought home one was the Bicycle and the Walkman, an introduction to materials design. And another one, which was the Philosophy of Everyday Things. So, Psychology of Everyday Things. And if you, kind of add those two together and you know me a little bit, you realize, that makes sense. So that's what I'm going with.
Excellent. Your nerdiness is very much appreciated. And to hear that your dad is a physicist and a material scientist is, it's awesome. And I'm sure your future clients and the people you work with will appreciate it, because a regular everyday architect isn't going to be able to throw together the materials that you did with the reasons why and answer those questions of, well, why do I use a PSL here? Or, what's the difference between this? That's the
That's-
big difference.
That also explains here. This is Merdad, one of the engineers. So explains actually the pain that he caused us through the
Always
project.
asking one more question. Can we do this? Can we do this? Can we do
No,
this?
no. Few more questions. You got to see his emails. They're always 5 pages long, and then they comes always at 1 a.m. in the morning. And luckily, my business partner is located in Switzerland. So until I woke up, most of the questions were already answered. So because of the time difference.
So, Merdad, was there anything on this that was stand out to you in terms of weirdness or interestingness or anything else?
Well, everything was interesting putting them together. You know, each of those materials for itself is being used everywhere, right? So, but bringing all this together like a laboratory, basically, and I'm putting them together, that was actually the most difficult part of it. As you mentioned, you know, 2x6 is not it's not 6 inches, or 2x8 is not 8 inches, right? And have them, all these materials basically playing into each other, and then also working. The problems with zip panels, with the NLT being cut shorter and right. That was the main, not obstacle, but just challenge that all of us had. Yeah, it's a small project, but it started. I think it started 4 years ago. Um, uh, Basically, when we started, and then since then, Ian was almost every night on internet, probably googling everything what he could Google, and then throwing at us. So yeah, it was a fun project.
Well, just like to point out that Madrid is probably, it's what I call a unicorn in the field of engineering, a structural engineer that embraces and agrees with Passive House. So, and agrees and works on mass timber. So we're going to go to Zach and kick off to the sponsors, but thank you guys very much.
All right.
Great.
Thanks a lot. Yeah, this is fantastic. So all of this work that we do would not be possible without our sponsors. So I really want to encourage everybody to support these companies. And I want to express my appreciation right now. So our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Mitsubishi Electric Train HVAC US, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are Innotech Windows and Doors, Morrison Hirschfield, and Partel. I'm going to advance my slide. Everybody see this with okay, awesome. So our Passive House podcast is has nearly reached 10,000 downloads, which is pretty exciting. This week's episode is with Luke Plowman of Detail Green in Australia. So it's up and live. So check us out on any channel of podcast listening that you subscribe to. Tomorrow, we will have our last Global Passive House Happy Hour of 2020. It's number 41. And it's called 2020 Wrapped and 2021 Envisioned. And we're going to do some celebration and then tap your brains for what you want to see in Passive House in the coming year, and ideas for the role that the Passive House Accelerator can play in helping realize some of those visions. So please join us tomorrow. Next week, the Passive House Accelerator Construction Tech Tuesday and Global Passive House Happy Hour are off. But the week after, first week of January, or actually this next week, even though those two things are off, we will have another podcast episode, this one with Sangeeta Sambandam of WRT, talking about a multi-family project in Connecticut that includes certification both through PHI and through FIAS. So check that out. And then the first week of January, January 5th, we kick off our first Construction Tech Tuesday of 2021 with Alex Hebert of BCIT. Thank you.